Hello students of Algebra 2, this is Mr. Hotard. Today we're going to be taking our first steps into a new unit on solving quadratic equations. Today specifically we're going to be doing what's called factoring quadratic expressions. It's very powerful stuff, so I'm going to teach it to you now so that you can experience the same thrill as this little woodland creature here. Before we get into the new material, factoring, we need to quickly review a concept that's old that you should already know. Just we need it in order to do this. Multiplying polynomials or multiplying functions. If I have x plus 3 times x plus 2, do you remember how to multiply those? I'd have to distribute each of these terms to each of these terms. Or FOIL, first, outer, inner, last. So x times x would give me x squared. X times 2 would be plus 2x. 3 times x would be plus 3x. And then 3 times 2 would be plus 6. And then that's not the final answer. I can combine like terms. My final answer would be x squared plus 5x plus 6. All right, that's multiplying. It's called binomials, 2 terms by 2 terms. All right, now, the lesson today is not on multiplying. All right, what we're going to be doing is factoring. We're doing the exact opposite of this. I'm going to be giving you this expression, and then you have to come up with basically the original problem, the things that could be multiplied together to get that expression. In fact, that is our first factoring problem, factoring x squared plus 5x plus 6. So we already know what the answer is. What I want you to do right now, just take a moment and look at it. What do these numbers in the answer, the 3 and the 2, what do they have to do with these two numbers in the problem? X squared plus 5x plus 6. These two numbers, 3 and 2, they multiply to give you what? To give you 6, the back number. They add to give me 5, the middle number. So when I'm factoring all of these quadratic expressions, I'm looking for two numbers that multiply to give me the back number, the 6, and add to give me 5. All right, so that'll be 3 and 2. So the order doesn't matter. I'm going to write x plus 3 and x plus 2, but you could also write x plus 2 first, then x plus 3. They multiply to give me 6. They add to give me 5. All right, so if we look at example 2, p squared minus 2p minus 8. I'm looking for two numbers that multiply to give me negative 8 and add to give me negative 2. So what are some possible numbers that multiply to give me negative 8? All right, there's 1 and there's negative 8. There's also negative 1, positive 8. What else? There's 2 and negative 4. There's negative 2, positive 4. Out of these all multiply to give me negative 8. Do any of these add to give me negative 2? Here it is. Positive 2, negative 4. So I can factor this into p plus 2 and p minus 4. Now again, the order doesn't matter. You could write p minus 4 and then p plus 2, but it does matter where the sign is. You have to have one positive, one negative, so that they multiply to give you a negative 8. And the bigger number has to be negative so that it adds to give you a negative 2. Now, why are we doing this? All right, the ultimate goal of this whole unit is to be able to solve quadratic equations, to actually find out what does x equal, or p, or whatever letter. All right, this factoring is the first step to doing that. All right, so before we do anything new, I want you to go ahead and pull out a sheet of loose leaf paper. I'm going to give you a couple problems right now. I want you to try to factor just like we did these. And I want you to try these 3 problems, just on loose leaf paper. M squared plus 8m minus 9, x squared plus 9x plus 18, x squared plus 9x plus 14. So just pause the video, take a moment, try these out. Did you do them? All right, let's check the answers. You should get m plus 9, m minus 1. Number 2, x plus 6, x plus 3. Number 3, x plus 2, x plus 7. Again, the order doesn't matter. So number 1, you could have said m minus 1, m plus 9. Next, let's look at some special cases of this. So this first one, example 3 right here, this is what we call a perfect square trinomial. You'll see what's special about this in just a moment. But just like the other problems, if I'm factoring this, I want to find numbers that multiply to give me positive 25 and add to give me positive 10. Can you think of any numbers? 5 and what? 5 and 5. It'd be a plus 5, a plus 5. Since it's the same number, All right, you could write it as a plus 5, a plus 5. However, if this had been a multiple choice question on the ACT or on a test, they wouldn't write it as a plus 5, a plus 5. They would write the factors as a plus 5 squared. All right, just because it's the same factors in both parentheses. So you could just write a plus 5 squared. So nothing really new there. And then a second special case, we call this a difference of two squares. If you look at this one, factor in h squared minus 49. Now, how is that different from all these other problems? It only has two terms. Every problem we've been factoring it's called a trinomial. It has three terms. This one only has two. It's got an h squared. It's missing the h. When that happens, the middle term is just 0. All right, so I'm still doing the same work I've done for all these others. When I'm factoring it, I'm looking for numbers that multiply to give me negative 49 and add to give me 0. So what are some numbers that multiply to give me 49? 7 times 7. All right, they got to multiply to give me negative 49. So what's that mean? Two positives, two negative, or a positive and a negative? One positive, one negative. So that means this is going to factor into h plus 7, h minus 7. All right, because 7 times negative 7 will give me negative 49. 7 plus negative 7, they cancel out to be 0. So basically, difference of two squares, you have to have the same number here in order to cancel out, just one positive, one negative. Now, I want you to write down what you think the factors are for example 5, x squared plus 36. Okay, what did you write? All right, I'm betting several of y'all, I'm betting you wrote probably one of these three things. When any year I give this, a lot of people write x plus 6 and x plus 6 or x plus 6 squared. Will that work? Not quite, because even though 6 times 6 gives you 36, do these cancel out to give you 0? No, that would give me plus 12x, so that way doesn't work. So a lot of people say, okay, well let's just make them negative. X minus 6, x minus 6. Does that work? No, because that would give you negative 12x. That doesn't give you 0. What if I make one positive, one negative? X plus 6, x minus 6. Well, that still doesn't work. Those will cancel out to give me 0, but what's 6 times negative 6? That'd be negative 36. If this had said x squared minus 36, that would be the answer. But this one, all right, you cannot factor it. It's not that it's no solution. All right, there are other ways of solving quadratic equations we'll get into later, but this one cannot be factored. All right, that's why we call it a difference of two squares. What's difference mean in math? It means subtraction. So if you have two perfect squares being subtracted from each other, you could factor it. If they're being added together, you're not going to be able to factor that. All right, now one other special case I just want to look at, we're going to add it on the side. So example 4, we said h squared minus 49. What if there was an extra number in front of this? What if, let's just add a little star here. One extra example, what if we had 4h squared minus 49, and I wanted to factor that? How do you think, having this 4 in front, how do you think that would affect these answers? Because 7 times negative 7 would still multiply to give me negative 49. They'd still add to give me 0. But I would need something in front of these h's. I would need 2's, because instead of just saying h times h gives me h squared, I would need a 2h and a 2h to give me 4h squared. So this would just factor into 2h plus 7, 2h minus 7. All right, still difference of squares. Still looking for numbers that multiply to give me that back number, cancel out to give me 0, but I would just have to put 2's on the h's so that they would multiply together to give me 4h squared. Remember, these factors we're writing are just something that you could multiply together to get back to the original problem. So now let's try a couple more on your own. So back on your loose leaf paper, I want you to try these three problems out. N squared minus 2n plus 1, a squared minus 25, 25k squared minus 9. Just factor these on loose leaf paper. Pause the video and try it now. Did you do them? I hope so. Let's see if you got them right. All right, the first one, negative 1 times negative 1 gives me positive 1, and negative 1 plus negative 1 gives me negative 2. So that's n minus 1 times n minus 1, or n minus 1 squared. Number 6, there is no middle number, so I need numbers that multiply to give me negative 25, add to give me 0. A plus 5, a minus 5. Number 7, I need numbers that multiply to give me negative 9, add to give me 0. So that's 3 and negative 3. But I need 5s on both of those k's so that they multiply to give me 25k squared. So 5k plus 3, 5k minus 3. Now the last type of factoring we need to look at. You notice almost every problem we've done today has started with what? X squared or a squared, just some variable squared. What happens if you have a number in front of the x squared? Ax squared plus bx plus c. Well, there's two types of those problems, type 1 and type 2, like diabetes. All right, we're going to look at just this first one right now. We call this the greatest common factor. All right, the second one we'll save for a later day. All right, but whenever you're factoring these problems, we haven't really discussed it yet, but you always want to look for a greatest common factor first, a GCF. Greatest common factor is something that can divide out of each of these terms in the problem. You always want to do that first. It can be a number, it could be a variable, or it could be a number and a variable. So you notice in example 6, 3u squared plus 3u minus 36, I can divide all of these by what? By 3. This one has a greatest common factor, a GCF of 3. So the way I factor it's going to look a little different. Don't split it up into two sets of parentheses yet. I'm going to write my GCF, my 3, right here in front, and then I'm going to put one big set of parentheses. And in that big set of parentheses, I'm going to write whatever's left when I divide everything by that 3. So 3u squared divided by 3 is going to leave me what? U squared. 3u divided by 3, that's just u, 1u, minus, what's 36 divided by 3? 12. Now remember, you should be able to always check your work by working backwards. If I distribute this 3 back to this, will it give me the original problem? Yes, it does. Now, this is correct, but it's not done. What's left? U squared plus 1u minus 12. I can factor that just like the other problems. So now I want to find two numbers that multiply to give me negative 12 and add to give me positive 1. What numbers multiply to give me negative 12 and add to give me positive 1? Well, let's see. There's 2 and 6. There's 4 and 3. One of them's got to be positive, and one of them's got to be negative to multiply to give me negative. So that's going to be, just bring the 3 down, not do anything with it, and then that's going to be u plus 4, u minus 3. Again, the order doesn't matter. If you want to write u minus 3, then u plus 4, that is correct. So this is completely factored. Greatest common factor first, and then factor whatever's left. Find numbers that multiply to give you the back number, add to give you the middle number. Example 7, let's try the same thing. If I want to factor this, I need to find the greatest common factor, 5w to the third minus 125w. This time, what can divide out of all this stuff? 5 can, but 5 is only part of the GCF. You notice all these terms also have a what? They also have a w. So in this problem, my GCF is 5w, not just 5. So I'm going to divide out 5w first. So I'll just have one set of parentheses. Now, 5w to the third divided by 5w, what do you think that is? It's w squared. Whenever you're dividing, you subtract the exponents. All right? Again, you could check because 5w times w squared will give me 5w to the third. And then minus, what's 125w divided by 5w? Is that going to be 25w or just 25? Just 25. W divided by w, the w's divide out. Now, again, we're not done. I can factor w squared minus 25. Just like these problems up here. Remember, the middle number is 0 if they don't have just a w or an x right here. So I need numbers that multiply to give me negative 25, add to give me 0. That's w plus 5, w minus 5. And then we're just going to bring down, don't forget to bring down that GCF. That's part of the answer. One last problem. All right, b squared plus 5b. Does this one have a greatest common factor? It does, but it's not a number. What do both of the terms have? They both have a b. So my GCF, my greatest common factor this time, is just a b. Sometimes it's just a variable. So let's divide that out, b. And then when I divide everything by b, what's b squared divided by b? It is just b. Plus, what's 5b divided by b? It is just 5. Now, you notice I don't have any b squareds or x squareds anywhere left in the problem. I can't factor anything else. That is completely factored. That is my answer. So you always, in every problem, always look for greatest common factor first. Could be a number, could be a variable, could be a number and a variable. All right, do that first, and then factor what's left. Look for what multiplies to give you the last term, adds to give you the middle term. And if it doesn't have a middle term, like this one, remember it's an automatic 0. So let's just try 2 more quick problems. Last 2 on your loose leaf paper. Try to factor these 2. 6n to the third plus 6n squared minus 72n, and 4x squared minus 12x minus 216. Look for greatest common factor first. So pause the video now. All right, let's see how we did. First problem, greatest common factor was 6n. Divide out the 6n, all right, and then factor what's left. That's going to factor into n minus 3, n plus 4. The second problem, divide everything by 4 first. Divide it all by 4, and then factor what's left into x minus 9, x plus 6. So now there's some extra practice for you to do. All right, on Google Classroom, I want you to try those out and bring that with you to class next week.